In this video, we'll cover how Curve Cyclic Sky simulates the movement of the sun throughout the day. Opening the basic settings menu, we look at the other parameters. The update button is used to update the settings. Usually you don't need to click on it. Any value change will be updated automatically. In individual, just open the level if you find the effect is abnormal. You can click on it and update it manually. Besides the time-related parameters we talked about last time, the rest of the parameters are mainly used to control the sun's movement trajectory and simulate the change of the real sunlight direction. CCS can simulate the movement of the sun in any region and in any season. It relies on several parameters. North offset is used to control the direction of north. The default is the northern hemisphere. The direction of negative light is north. The sun usually favors the wide direction. Here, this arrow points to the current position of the sun. Change this value to offset the sun horizontally in degrees. Maximum sun angle is used to define the highest sun angle in a day. This is usually the 12 o'clock sun angle. It can simulate changes in the sun's motion caused by most dimensions and dates. Change solar time to 1200 and look at the sun angle. Currently, we have a maximum sun angle of 70. You can see that the sun angle is indeed 70 degrees. Next, turn on Advanced. Let's take a look at dawn time and dusk time. They are used to control the sunrise and sunset time. Let's change the solar time to 600 and try it. We can see that the sun angle is now 0 degrees. Change dawn time to 700 because it is now 6 o'clock. Not yet sunrise time, so the sun is below the horizon is a negative angle. We will adjust the time to 7 o'clock. You can see that the sun angle degree is now 0. Winter style summer offset is used to simulate the effect of different seasons on the direction of the sun. For example, in most parts of the northern hemisphere in the summer, the sun is not always in the south direction. The sun will be in the northeast and northwest direction at sunrise and sunset. Let's demonstrate this. First, set the time to 1200. And adjust the maximum sun angle a little bit lower so that we can observe it easily. Drag the time to a period close to sunset. The sun is due west at sunset. Now turn up the winter solar-summer offset. We will notice that the sun is shifted to the north during sunrise and sunset. This gives us a simulation of the sun's movement in the northern hemisphere during the summer months. Simulate real dawn sawdust time. This parameter is used to simulate changes in the length of day and night due to dimensions and seasons. Let's enable it and set winter sol summer offset to a positive value to represent the northern hemisphere summer and see the results. Set the time to 6 o'clock and see that the sun angle is now not 0 and there is no sunset yet. The larger the value of winter sol summer offset, the closer it is to the summer solstice, the longer the day and the longer the night. In this way, you can simulate the change of day and night. It should be noted that when simulate real dawn time, dusk time is enabled. Dawn time and dusk time can't specify the time precisely, but they will still have the effect of offset. If you want to simulate the effect close to the real one, you need to restore them to the default values. Theoretically, if you know the maximum altitude angle of the sun for a certain region, a certain date, and also the angle of the yellow equinox for that date, input it to winter, last summer offset, then you can simulate the real sun movement CCS did not choose to control the solar motion by inputting the latitude, longitude, and date because it is not intuitive to control in this way. And in most cases, we would like to be able to control it directly. Now we can easily control the point in time when day and night alternate the sun's altitude, angle, and the direction.